The National Electrical Code, or NEC, does indeed require load calculations to be performed to ensure proper sizing of the main breaker when derating for a backfed solar photovoltaic, or PV, system. Specifically, NEC section 220.87b addresses this situation. This section stipulates that where a backfed breaker is installed, a load calculation shall be performed in accordance with Article 220 to ensure that the feeder is adequate after the application of the derating factor required in 220.87a. The purpose of this requirement is to guarantee that the main breaker, even after being derated, maintains sufficient capacity to handle the combined load of the existing electrical system and the power potentially fed back from the solar PV array. Derating the main breaker inherently reduces its current carrying capacity. Therefore, a thorough verification process, which is the load calculation, becomes essential to confirm that the remaining capacity adequately covers the demands of the system. To elaborate further, it's important to understand the implications of connecting a solar PV system to an existing electrical panel. The solar PV system, through the backfed breaker, injects power into the panel, effectively reducing the amount of power that needs to be supplied by the utility grid. However, this also means that the main breaker, which is designed to protect the entire electrical system from overcurrents, now has to account for the potential backfeed from the solar PV system. The 120% rule, often mentioned in these scenarios, stems from NEC 705.12d2, which deals with supply-side connections. However, in the context of a load-side connection, as we're discussing, the primary concern is ensuring that the main breaker is appropriately sized after derating. To determine the appropriate size of the main breaker after derating, a load calculation must be performed according to Article 220 of the NEC. Article 220 provides detailed instructions on how to calculate the load of a building or electrical system. The calculations take into account various factors, such as the square footage of the building, the number of appliances, the lighting load, and any other electrical equipment that may be connected to the system. When calculating the load for a system with a backfed solar PV breaker, the load calculation must also account for the maximum potential output of the solar PV system. This is typically done by adding the rated current of the backfed breaker to the existing load of the system. Once the total load is calculated, the main breaker must be sized to protect the system from overcurrents. The NEC requires that the main breaker be rated at not less than the calculated load. In addition, the NEC also requires that the main breaker be sized to protect the conductors that supply the system. The conductors must be rated to carry at least 125% of the continuous load, and the main breaker must be sized to protect the conductors from overcurrents. It's crucial to recognize that providing load calculations in this situation is not merely an excessive or unnecessary step. It's a fundamental aspect of professional responsibility. Ensuring that the electrical system is both safe and properly sized is paramount. Simply resorting to nuisance tripping as a solution is unacceptable. Nuisance tripping can mask an underlying electrical problem and, in worst-case scenarios, can lead to more serious issues, including electrical fires. Consider a scenario where the derated main breaker is too small to handle the combined load of the existing system and the solar PV backfeed. In this case, the main breaker may trip frequently, especially during times of high energy demand. This can be a major inconvenience for the customer, and it can also damage electrical equipment. Furthermore, frequent tripping can indicate that the electrical system is overloaded, which can increase the risk of electrical fires. Therefore, it's essential to perform a load calculation to ensure that the main breaker is properly sized. Let's delve into the specifics of performing a load calculation. Firstly, gather all the necessary information about the existing electrical system. This includes the square footage of the building, the number of circuits, the size of the main breaker, and the ratings of all major appliances and equipment. Secondly, calculate the general lighting load. The NEC provides tables that specify the lighting load per square foot for different types of occupancies. For example, a dwelling unit typically has a lower lighting load per square foot than a commercial building. Thirdly, calculate the small appliance and laundry loads. The NEC requires that each small appliance circuit be calculated at 1500 volt amps. The laundry circuit must also be calculated at 1500 volt amps. Fourthly, calculate the appliance loads. This includes the loads of all major appliances such as refrigerators, ranges, water heaters, air conditioners, and electric heaters. The NEC provides tables that specify the typical loads of these appliances. Fifthly, calculate the heating and cooling loads. The NEC provides different methods for calculating heating and cooling loads depending on the type of heating and cooling system. Sixthly, calculate the other loads. This includes the loads of any other electrical equipment that may be connected to the system, such as motors, welders, and electric vehicle chargers. Seventhly, add up all the loads. This will give you the total calculated load of the existing electrical system. Eighthly, determine the maximum potential output of the solar PV system. This is typically provided by the solar PV system manufacturer. Ninthly, add the maximum potential output of the solar PV system to the total calculated load of the existing electrical system. This will give you the total load that the main breaker must be able to handle. Tenthly, select a main breaker that is rated at not less than the total load. The main breaker must also be sized to protect the conductors that supply the system. In addition to the load calculation, it's also important to consider the impact of the solar PV system on the voltage drop in the electrical system. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. Excessive voltage drop can cause appliances and equipment to malfunction. The NEC provides guidelines for minimizing voltage drop in electrical systems. When installing a solar PV system, it's important to ensure that the voltage drop is within acceptable limits. This may require increasing the size of the conductors or installing a voltage regulator. Furthermore, it's critical to ensure that all work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. They should also have experience installing solar PV systems. A properly installed and sized solar PV system can provide significant benefits, including reduced energy costs and a smaller carbon footprint. However, it's essential to prioritize safety and ensure that the system is installed in accordance with all applicable codes and standards. Remember, the NEC is not just a set of rules. It's a comprehensive document that is designed to protect people and property from electrical hazards. By following the NEC, you can help ensure that your electrical system is safe and reliable.